Hi my dear students, today in our electronic device and circuits we are going to start a new chapter called Multistage and Feedback Amplifiers, under which our today's topic is classification of amplifiers. The agenda of the today's class is here upon the completion of the period you will be able to know the classification of amplifiers on the basis of frequency, the classification of amplifiers based on frequency, and the classification of amplifiers on the basis of number of stages, the classification of amplifiers on the basis of coupling, and finally the classification of amplifiers on the basis of feedback. And the need for multi-stage amplifiers. The need for multi-stage amplifiers. In the earlier class, we have already discussed about the transistor load line analysis, that is AC load line analysis, DC load line, drawing the AC load line, DC load line, and selection of operating point, that is a quotient point, Q point, by using this AC and DC load line. See, the operating point is the intersection point of AC load line and DC load line. And stabilization. What is the stabilization? See, making the transistor output independent of temperature variations and transistor parameter variations. How to make these parameters independent? That is by using proper biasing. So, this biasing methods, we have also discussed the biasing methods like collector to base bias and self bias or universal bias, that is also called as a potential divider bias, okay, fixed bias. All these biasing methods we have discussed in the earlier classes. Okay, so why this biasing is required? To select proper operating point and stabilization of this transistor amplifier. See, amplifier. What is an amplifier? An amplifier which rises the given signal strength. See, if you give a small amount of signal at the input of the amplifier, then it rises the signal levels and gives as a output. That is the function of the amplifier. So here a small signal amplifier. What is a small signal amplifier? Means which gives some small amount of amplification. Of course, it rises the signal, but the amplification range is small. See here, the fluctuations in the collector current are small compared to its quiescent value. See, that is, see, if it is a common emitter amplifier, in a common emitter amplifier, as we know, the amplifiers mostly used are in a common emitter mode. See, that is a transistor configurations: common base, common emitter, and common collector. Out of these three configurations, we use mostly common emitter configuration. Okay. Uh, Under this common emitter configuration, if you give the input at the base, the output is collected at the collector. So, this collector current variations are small as compared to the quiescent value. See, the small signal amplifiers are also known as voltage amplifiers. That means which increases the voltage level. If you give a input in the form of millivolts, then you get the output in volts. And these small signal amplifiers are mostly used in the first stage of the amplifiers. That means we are not going to use a single amplifier. See, there are number of stages. Okay, In this, the first stage of the amplifiers are the small signal amplifiers. All these are used in radios, uh, television receivers, tape recorders, stereo systems, and measuring instruments, etc. The classification of amplifiers. Classification of amplifiers based on the frequency. See, the frequency, if you go for the frequency, it starts from 0. The 0 frequency is known as DC frequency. DC amplifiers. So, DC amplifiers starting from 0 to 10 hertz, very low frequency. DC amplifiers deals with a very low frequency, that is 0 to 10. So, amplifying the DC signals or a slowly varying currents or voltages, because the frequency is very low. And audio frequency amplifiers. Audio frequency amplifiers, the name itself indicating audio frequency range. The audio frequency range is 20 hertz to 20 kilohertz. So here the audio frequency amplifiers are going to amplify the audio signals that is used in the sound systems like public address systems. The next one is IF, intermediate frequency. IF stands for intermediate frequency. These amplifiers, intermediate frequency amplifiers, amplify a single frequency which is known as IF. And the next one is radio frequency amplifiers. Radio frequency which is above the 20 kilohertz. The radio frequency amplifiers are nothing but the signals which is going to be radiated in the air. Okay, of course we can also use RF in a cables also. Okay, so radio frequency amplifiers which is above 20 kilohertz amplify the frequencies of signals above 20 kilohertz is usually much higher. And the last one is a video amplifiers or video frequency amplifiers which is up to few megahertz. As we know, the video signal frequency range is very high, so which is up to megahertz. So which amplifies the signals for the wide range of frequencies, that is used to amplify the video signals in televisions. Okay, where we are going to watch these videos and usually in televisions. So here the video frequency amplifiers are used in television systems, right? And based on the number of stages, the classification of amplifiers based on number of stages. See here, if you use a single transistor amplifier, then it is called as a single stage amplifier. And if you use a number of amplifiers connected to each other, the output of the one stage of the amplifier is connected to the next stage, then this is known as multi-stage amplifiers. Because in a practical conditions we are not going to use a single amplifier, so we require a large amount of amplification. So here we are going to use multiple amplifiers by means of cascading. Okay, so here the number of, based on the number of stages, classification of amplifier is single stage amplifiers and multi-stage amplifiers. Here the multi-stage amplifiers are further classified into, based on the type of coupling, RC coupled amplifier. Here the coupling stands for the connection of one stage to the next stage. How we are going to connect one stage to the next stage, that is RC coupled amplifier. Here we are going to use a resistor and a capacitor to couple the two stages. The next one is a transformer coupled amplifier. Here we use a transformer as a coupling device. And direct coupled amplifier, the name is itself indicating that there is no coupling device used. We are directly connecting the one stage of the output to the next stage. Directly in the sense a simple wire is going to be used, and impedance coupler. So here we are matching the impedance. Okay, impedance coupled amplifier. Based on the number of stages, single stage amplifiers when only one transistor with associated circuit is used for amplifying a weak signal. The circuit is known as the single stage transistor amplifier. So, as we discussed, only one transistor is used to amplify the signal, to amplify the weak signal. Okay, here is a diagram which showing the single stage amplifier. A small 0.6 volts is given as a input, and which is giving a 7 volts of the amplified signal. Here we are assuming, because this amplification range varies depending on various factors, transistor, beta factor, all those factors. Okay, uh, and now here just for assumption purpose we are taking 0.6 volts as a given input voltage, and we are getting 7 volts as a output. Okay, and now multi-stage amplifiers, a circuit containing more than one stage of the amplification, more than one stage, as the number of single stage transistors are connected in cascading arrangement, because as we know, uh, one stage of the amplifier is connected to the next stage, that is the output of the one stage is connected as input of the next stage. So here the diagram shows the multi-stage amplifier. The amplifier stage 1, the amplifier stage 1, here amplifier stage 1 is connected to the amplifier stage 2. In amplifier stage 2, output is connected to the amplifier stage final stage or third stage. Likewise, where we can use as many stages as required. And finally, the output is given to the RL, that is load. Okay, here the amplifier stage 1 and amplifier stage 1 output is given to the amplifier stage 2. Likewise, it is finally given to the final stage, and we are getting the output. This amplified output is given to the RL. Now, need for multi-stage amplifiers. Need for multi-stage amplifier. What is the need for multi-stage amplifier? Of course, we can. Why can't we use a single transistor amplifier for amplification? Why we are going for this? All these multi-stages, multiple stages, multiple number of stages. See, let us see. An amplifier is the basic building block of the most electronic systems, and the output from a single stage amplifier is usually insufficient to drive an output device. Let us take an example of a public address system. If there is no public address system, or a single transistor amplifier is used to amplify the voice signal. Let us take an example. Okay, a person want to give a speech in front of for example, let us take our college as an example. Okay, uh, here we are conducting a uh, college day, or we are celebrating a college day, and our principal sir is giving a message to the students. You want to give a message to the students. There are around 1500 students in our college, and if you want to speak If you want to give the message, it is not audible to all the 1500 students. If he directly gives the message, then what we are going to do, we use an amplifier, a mic and amplifier in between and a loudspeaker, of course. uh, but if the amplifier is having only a single transistor amplifier, then what will be the condition? The amplifier amplifies, but the amplified range is very small. The amplified signal is very small. Even though we are using the amplifier output which is not sufficient or which is not audible to all the students, then what we do, we use large number of amplifiers to get the high output, and we use high capacity loudspeakers. That is uh, if you if you take an example of DJ system, it will be in a thousand in an amount of 1000 watts. Say uh, generally in our audio systems like home theater systems, we'll get 600 watts, 1000 watts, 1500 watts, 2000 watts, like that. So as the wattage increases, the capacity of the output capacity of the sound system increases. See, if you want to give, if you need more amount of output, then how it is able to give such a high input signal to the loudspeakers? That is possible with only the multiple number of amplifiers. If you use a single transistor amplifier, it is insufficient to drive such a high load. So that is the reason why we need to use multiple stages. The additional amplification over 2 or 3 stages is necessary to get the desired output power. So to achieve this, the output of one stage is connected to the input of the next stage. So first stage amplifies the signal level to some small voltage. See, after that, the second stage is now amplifying further. The amplified version of first stage is given as the input of the second stage. So this amplified version again amplified. That means the amplified signal is amplified further. So the second stage gives a further amplification. This signal again given to the third stage. Third stage gives a further rise in the output of the amplifier, and this amplified signal again further connected to the next stages like fourth stage, fifth stage, and finally we got our required output. The resulting system is referred to as the multi-stage amplifier or a cascaded amplifier. The interconnection of amplifiers is called as cascading. High gains can be obtained from a multi-stage amplifier. To get the required gain, we are using the number of stages or multi-stage amplifiers. So to get the required gain, we use the number of stages. How many number of stages will be dependent upon the required gain. And multi-stage amplifiers, a transistor circuit containing more than one stage of the amplifier is known as a multi-stage amplifier. Okay. A number of single stage amplifiers are connected in a cascading arrangement. It's also called as cascaded amplifier. The output of the first stage is connected to the input of the next stage through a suitable coupling device, and so on. See here, the output of the first stage is connected to the next stage by using a coupling device. That is, a connection of one stage to the next stage is based on coupling. Say, as we discussed, it is RC coupled, transformer coupled, and direct coupled. Okay. This kind of arrangement is called as cascade. So here the multi-stage amplifier block diagram. First stage a coupling device, second stage a coupling device in third stage, and so on. The first stage amplifier consisting of a basic transistor and which is properly biased by using voltage supply and biasing methods, like if you go for generally here we use a universal bias, that is a self bias. Okay, potential divider resistors will be there and emitter resistor, emitter bypass capacitor, all will be there in the first stage, and then it is given to the second stage by means of coupling. Here the coupling devices are generally RC coupled, transformer coupled, or directly coupled, and this is now connected to the second stage, and in a similar manner it is connected to the third stage. Okay, how to couple these stages? So we use a suitable coupling network between the two stages. Okay, the purpose of coupling device is, what is the purpose of this coupling? Of course, if not coupling devices are not used, then what happens? See, to transfer AC output of one stage to input of the next stage. See, the amplifier is amplifying the AC signal. Here also we are using DC signal for the purpose of biasing. The DC isolation of one stage from the next stage is necessary. So for that reason we need to use a coupling device. Here only AC signal must be transferred to the next stage, but there should not be any DC signal, and we need to isolate the DC signal conditions of two stages. If it is not done, then what happens? There will be a loading effect and the operating point or stabilization will be affected. Operating point may change and there may not be a stable output. So for this reason, we must use a coupling device between these two stages. And based on the coupling, as we know, RC coupled amplifier, the coupling device, if you use a resistor and capacitor as a coupling device, then it is RC coupled amplifier. If you use a transformer, then transformer coupled amplifier, and if you use a simple wire, there is no coupling device, then direct coupled amplifier, and finally impedance coupled amplifier. Let us see how the RC coupled amplifier will be. See, there are two transistors connected each other by using a resistor and capacitor. So here the resistor and the capacitor. Then it is known as RC coupled amplifier. Capacitor is used as the coupling device, resistor and capacitor. The collector capacitor, RC collector resistor, the capacitor in combination. Now we call this as RC coupled amplifier. So the output in a transistor 1, the output in a transistor 1 here and here, which is given to the transistor 2. The output of the transistor 1 through collector resistor RC, and which is now connected to the base of the transistor 2. Now the further amplified signal appears across the RC2, which is now the output of this second stage of the transistor. Transformer coupled amplifier. The transformer coupled amplifier, here you see the transformer is the coupling device here. Transformer is the coupling device. The first stage transistor output is given to the next stage by using the transistor. Here the output which is appearing at the collector is now in the primary of the transistor. Due to mutual inductance, the output is now collected in the or given to the base from the secondary of the transistor. Okay, now the second stage transistor amplifying it further, it is collected across the collector of the second stage. This is the final output. Okay. Impedance coupling, which is used for impedance matching. Here the black circuit diagram shows the impedance coupling circuit. Here see inductor and capacitor in combination is now providing the impedance coupling. See here an inductor and capacitor. Direct coupling. Here in direct coupling there are no coupling elements. The collector of the first transistor is directly connected to the base of the next transistor by using a simple wire. A wire is used as a coupling device here. This is a direct coupling. Now the classification of amplifiers based on the feedback. See, till now we discussed the classification of amplifiers based on the frequency, based on the number of stages, based on the coupling, and also we discussed the need for multi-stage amplifiers. Now we are going to discuss the classification of amplifiers based on the feedback. Here we have two types under the feedback amplifiers: positive feedback amplifier and negative feedback amplifier. Here what is a feedback? What is a feedback? The feedback is the name itself indicating feeding it to the back. See, the output of the amplifier signal is again fed back to the input. That is, the output of the amplifier is connected to the input again. That is called feedback, and this feedback is of two types: positive feedback and negative feedback. If the feedback is regenerative, that is, which aids with the input, that means which increases the input, the original input and the output from the amplifier both are aided together, now which is called positive feedback. Negative feedback means it is a degenerative feedback. Degenerative in the sense the original input will be subtracted from the feedback, then the overall input will be reduced, which reduces the output further. This is degenerative or negative feedback. How it is going to be happen? See, let us see the block diagram for the feedback amplifiers. So, here the input signal source is connected to the basic amplifier through a comparator network or a mixer network. The basic amplifier initially amplifies the signal and which is given to the sampling network, is given to the sampling network. The sampling network, and this is now some portion of this output is given to the input by means of a feedback network. A feedback network. Here from the by using the feedback network, the fraction, the multiplication factor is beta, and this is again combined by using the mixer or combining network with the input signal, and now it is given to the amplifier again. So, like that this cycle repeats. If it is a regenerative, then it is called as positive feedback. If it is a degenerative, then it is called as negative feedback. And also we classify the amplifiers based on the function. There is a voltage amplifiers, power amplifiers. Voltage amplifiers increases the voltage level, power amplifier increases the power level of the input signal, which we are going to discuss in detail in the upcoming chapters. Okay, and the based on the magnitude of the input, that is how much input we are giving to the input of the amplifier. Small signal amplifiers, large signal amplifiers. Example for small signal amplifiers, voltage amplifiers, and the example for large signal amplifiers are power amplifiers. The type of load connected, that is untuned amplifiers. Untuned amplifier means resistors are used as a load. Tuned amplifiers, here circuit is used in the collector circuit. Tuned circuit is used, there is a combination of inductor and a capacitor. IF amplifiers and RF amplifiers are going to use this tuned amplifiers. Here you see a single tuned amplifier, double tuned amplifier, and a stagger tuned amplifier. The diagram which is not shown here. A single tuned amplifier means at the collector side, if you observe here, a capacitor and inductor both in combination, here we are used for tuning, single tuned, and here double tuned amplifier, double tuned both at the collector side and output side, double tuned amplifiers. Okay, and based on the period of conduction, the amplifiers are classified into class A amplifier, class B amplifier, class C amplifier, and class AB amplifier. Class A amplifier. Class A amplifier, the position of the Q point and the portion of the characteristic that is used to determine the method of the operation. See here, the Q point, here we are going to vary. In the class A amplifier, the Q point is located at the middle of the load line, so that we get a complete operation. The amplifier will work for the full cycle of input signal. Here the diagram shows 360 degrees of the conduction. And a class B amplifier, here the collector current flows for only the half of the cycle. See here, here I am applying a 360 degrees cycle as an input to the class B amplifier, but I am getting only half cycle here, that is only for the period of 180 degrees. Okay, such that here the class B amplifier is uh, biased such that only the Q point is selected such that only it is it should operate only for the 180 degrees duration. So this is class B operation. In class C amplifier, the collector current flows for less than one half of the input signal cycle. That is, the collector current is in the form of pulses. So the conduction angle is, that is 180 degrees, less than 180 degrees. As the definition itself saying that the current flows for less than one half of the input signal, that is less than 180 degrees. So see here how it is. If I apply a full cycle of input, then but I am getting only output which is less than the one half of the input signal, that is less than 180 degrees. See, if you observe the between this 0 and pi, so it is less than this 180 degrees. And the class AB amplifier, it is a combination of class A and class B amplifier. The collector output current for the class A amplifier, it conducts for entire 360 degrees, and class B it conducts only for 180 degrees. The class AB is in between class A and class B. So the collector output current flows more than one half cycle but less than one complete cycle. So in between class A and class B operation. Okay. It operates between the two extremes of class A and class B. See here, the output will be like this for class AB operation, that is in between 180 to 360 degrees. So here in the today's class, we have discussed the classification of amplifiers. So the summary of the today's class. So based on the frequency, based on the load, and the classification of amplifier based on the period of conduction, based on the number of stages we have classified, and also based on the function. See, based on the frequency, we have classified the amplifiers into AF and IF, that is audio frequency, intermediate frequency, radio frequency, and video frequency. And based on the load, there are two types, that is untuned and tuned. So under the tuned amplifiers, again it is a single tuned, double tuned, and Strager tuned. The classification of amplifiers based on period of conduction. Period of conduction, that is class A, class B, class C, and class AB. Based on the number of stages, single stage, multi-stage. The multi-stage amplifiers are further classified into RC coupled, transformer coupled, direct coupled, and impedance coupled. Multi-stage amplifiers, we have also discussed about the need for multi-stage amplifiers. Finally, the classification of amplifiers based on the function, that is voltage amplifiers and power amplifiers. Okay, so this is all about the today's class. And now let us go through a small quiz. In RC coupled amplifier, the coupling elements are A. Inductor and wire. B. Resistor and capacitor. C. Diode and transistor. D. None of the above. Are you able to answer this question, dear students? What will be the answer for the question? See, read the question carefully. In RC coupled amplifier, the coupling elements are, the question itself containing the answer, RC coupled. There is resistor and capacitor. Resistor and capacitor are used as a coupling elements for this RC coupled amplifier. And the number of stages in multi-stage amplifiers are, and how many number of stages will be there in multi-stage amplifiers? A 1, B 2 stages, C 2 or more stages, D 3 stages. Which will be the correct answer for this question? Can you guess, students? Multi-stage, multiple stages. Multiple stages in the sense it can contain any number of stages, that is, but it is not a single stage. So 2, if it contains 2 stages, of course it is a multi-stage. 3 stages, of course multi-stage. 4, it is also multi-stage. So I can say 2 or more stages, then it will be a multi-stage amplifier. Right. Questions may be asked in the final examinations or mid exams. See, classify the amplifiers based on the frequency and based on the coupling. And classify the amplifiers based on the uh, feedback and based on the number of stages. State the need for multi-stage amplifiers. These are the questions that may be asked in a examination. Okay, my dear students, so this is all about today's class. Okay, we'll discuss the next topics in another class and meet you in the next class. Have a good day. Bye.